Hello everyone. So let us discuss inversion of matrix. So it is a very important topic. So far as linear equations are concerned, to find out the solution of the variables in a linear equations, we must find out the inversion of the coefficient matrix. So what are the criteria? There are about 4 important criteria of inversion of a matrix. Now first is, take a coefficient of a square matrix. So matrix should be square. Then find its determinant. After finding out the coefficient of the square matrix, then we'll have to find out the determinant of this. Then find cofactors of the element. Then for every element, we'll have to find out the cofactors. Then take the determinants of the minors of the cofactors. So when we'll eliminate the row and the column where the element stands, we'll get the minor, then determinant of the minor. Then transpose the coefficient matrix and form adjoint matrix. So what coefficient we'll get, then we'll have to transpose it. Then we'll get adjoint. Now adjoint divided by determinant of the coefficient matrix will give the inverse matrix. Let us see. So solution of a linear simultaneous equation system through matrix algebra. So let the equations are x1 plus 2x2 plus 3x3 is equal to 14. Then x1 plus 3x2 plus 5x3 is equal to 22. Then x1 plus 5x2 plus 12x3 is equal to 47. So these are the 3 simultaneous equations, 3 equations, 3 unknowns. Now we have to find out the value of x1, x2 and x3 so that the equations are satisfied. So now coefficient matrix 1, 2, 1, 2, 3, 1, 3, 5 and 1, 5, 2. So it is a 3 by 3 square matrix. Then X matrix, x1, x2, x3. Then solution factors B is equal to 14, 22 and 47. It is 3 by 1 matrix. Sorry. Then equations can be expressed. Now the whole system can be expressed as AX is equal to B. So X is equal to B by A means A inverse B. Now coefficient matrix should be non-singular. As I said earlier, so if the determinant of the coefficient is 0, it is a singular matrix, so it should be non-singular. So that determinant is not 0 and inversion is possible. So cofactors and minors, they are very much closely related. Cofactor is denoted by Cij. So if we expand I and expand j, we will get C11, C12 and so on. We will get the coefficient, the cofactor matrix, and its value is, as we have already got it earlier, is a minus 1 to the power I plus j into minor mij. So sign is determined by this formula, minus 1 to the power I plus j. Suppose element is 1. So this is A11. Then strike out the row where it stands and strike out the column where it stands. So minor is 3, 5, 5, 12. 3, 5, 5, 12. So determinant of that. Okay. So where the Mij is a minor after eliminating the row and the column where the element Aij stands. Now determinant of A is equal to, now we'll have to find out the cofactor now. So minus 1 to the power 1 plus 1 for the first element. So 1 into 3, 5, 3, 5, 5, 2. So plus minus 1 to the power 1 plus 2 into 2, 1, 5, 112. 1, 5, 112 for this element. Then for third element, this is 1, 3. So plus minus 1 sign will be determined by this to the power 1 plus 3, 3 into 1, 3 and 1, 5. So ultimately after simplification we will get that minor is 3. Determinant is 3. Now replacing elements by cofactors Cij, so 11 minus 7 2, minus 9 9 3 and 1 minus 2 1. Okay. So Cij, that means cofactor matrix, will be 11 minus 7 2 minus 9 9 3. You see, for this element 36 minus 25 is 11. Then for this 12 minus 5 is 7, and for this third one it is 5 minus 3 2, like that. Then for the likewise for the second row and third row, so like this. So Cij, that means cofactors matrix will be 11 minus 7 2 minus 9 9 minus 3 1 2 minus 2 and 1. Now adjoint of this, so this will need a little homework to find out this. I have estimated for 1, so for second and third row, so this will need some homework. Okay. So adjoint, that means make the rows columns and columns as rows. So if we find out the adjoint of this, it will be 11 minus 9 1. It was column, here it will be row. Then minus 7 9 minus 2, minus 7 9 minus 2, it is a column, here it will be row, like that. So Cij prime, this means transpose of this is this. Now what is, so this becomes the adjoint. So what is A inverse? Adjoint divided by determinant. Then we adjoint divided by 3. So each element should be divided by 3. Each element should be divided by 3. Okay. So by doing this, we will find then x1 is equal to 11 by 3 minus 3 and 1 by 3 after dividing by this, multiplied by 14, 22, 47. So if we multiply this into this plus minus 3 into 22 minus 1/3 into 47, this will give 3 by 3 is equal to 1. So value of x1 is equal to 1. So similarly, we will find that x2 is equal to 2 and x3 is equal to 3. Now putting these values in the linear equations, we will find that all the three linear equations are satisfied. That means, suppose x1 is equal to 1, 1 plus here it is 2, 4, 1 plus 4, 5, plus here it is 3, 9. So 5 plus 9 is equal to 14. So likewise, we will find that the second equation, third equations all are satisfied with this. Now we will find that use of Cramer's rule can also find out the inversion of the matrix. Let us wait.